two things I've noticed. The first is that the displays run quite hot at 5 volts. So I've dropped all the circuitry down to 3.3 volts, which makes it a little dim, to be fair, but they don't get quite so warm. And I'll have to revisit whether or not I want to run at 5 volts at a later date. But in the meantime, there it is. The other thing I've noticed, and you may have spotted this at the end of the last video, is when I change the frequency, so for example, put it down to 0, you can see that the clock does stop and then it starts doing weird stuff. I can put the clock back up and it resets and carries on. So this means that I can't stop and start the clock as a means of stepping through a program on the processor. To get the step through working, the first thing I need to work out is what ready does. Now in the original circuit I've just pulled that high via a resistor. It basically allows the flow of the program. If you take ready low at an appropriate time, it will stop the processor from carrying out any additional tasks. According to the manual, this is to allow interfacing with low speed memory as well as low speed things on the address bus. In order to make that work in line with what the processor's doing, there's the sync line on the processor, and what this does is it pulses as it enters a particular stage of running an instruction. So in theory at least, one can use the sync signal to set the ready signal. Adding a bit of logic to that, we should be able to just take ready low and keep it low and then use a push button to step through the program, all at the same time as not affecting the clock whatsoever and therefore not interfering with the flow of the processor's program. So the circuit, and you can just about see it on the right hand side because I've already built it, is something like this. On the left hand part of the diagram you can see S2 step mode with a decoupling capacitor, because I'm old, which is used as a signal to toggle the output Q on pin 9 of the 74HC73JK flip-flop, or at least the one section of it. Now, using a push button and a resistor to create a clock pulse is probably not the best way of doing it, but we'll try and we'll see what it does. The output of that, Q, is fed into an AND gate, which is ANDed with the sync signal. The step mode JK will gate the sync signal. So if step mode is enabled, the output of the AND gate will be the sync signal. If the step mode is disabled, the output will just be 0. The output of that AND gate is fed into the next JK flip-flop, such that if the step mode is switched on, it will pulse the sync signal onto the J, which means when the clock is pulsed as well, the flip-flop is activated. Because the JK flip-flop is a latch, regardless of what else the clock and the sync signal does, the flip-flop will remain in that state until such a time as S3, the step button, is pressed. At which point, on the next clock cycle, the flip-flop will then return to its original state and the ready signal will be sent high. The resistor and LED connected to not Q on the first JK flip-flop is just an indicator to show whether or not step mode is enabled or not. So the processor is clocking away quite happily. If I put it into step mode, try again. Light comes on and it stops. I can then step through it by pressing the step button. If I press and hold the step button, it carries on normally and I can let go and it stops, which is kind of cool. I can then take it out of step mode. Apparently it takes 2 button presses, but it doesn't automatically carry on until I press the step button, and then it will carry on automatically again. How cool is that? One press of the button that time. That's a quick redrawing of the circuit, and you can see that I've included U3B, which is essentially just buffering the clock signal from the push button. We'll see in a minute if it makes any difference, but what it's supposed to do is just change the signal coming from the push button, and with its inherent capacitive and resistance network, from something that rises quite slowly to a crisper edge for the clock signal. Whether it does that or whether it just creates a multiple pulse, I don't know yet. I could put it on the scope to see whether or not it does that, but to be honest, it's not that important at this stage. I've added an AND gate between the step mode button and the JK flip-flop just to clean up the signal a little bit, so that in theory at least, when I press the button, and that's made no difference. Well, no, to be fair, it is better. Mostly it comes on and off when you press it, though occasionally it gets confused and it doesn't turn off properly. But that's okay. And again, if you want to go carry on counting it, press the go button. That's really awesome. I'm absurdly chuffed with myself over that circuit. When we reset, it jumps to EAE9, which would seem to be pulling the information off the data bus for the address. And if we then step, well, that's slightly bizarre. I wasn't expecting that to do whatever it was doing, but it seems to have now settled on EAEB. We step again. It seems normal program flow. How bizarre. The moral, however, does appear to be that you need to make sure that your start address is presented on the data bus upon boot. And that information will be stored in memory somewhere, but I'll have to have a look in the documentation, I suppose, to figure out where in memory that's stored. Let's set it going again. So, one of the problems that I've got with the design that I've come up with for the single step is that it doesn't work at higher frequencies. And this is because it's using the clock as a trigger mechanism. Looking at the display, we can see the display is going nuts. This is currently at 10 kilohertz. If I pause it, thus, it works fine. It does exactly what I want it to do. It stops it dead. And then if I step through, you can see that we're jumping ahead a load of steps each time I press the button. Yeah, it's not ideal. I might have to think about what to do about that in the future. But at the moment, I'm happy with running it at 10 Hz and the step through working. Maybe when I start to think about what sort of clock I'm going to put on the circuit, rather than using an external one, I will make it so that it always uses the 10 Hz clock or a 10 Hz clock for any step through. Yeah, that seems reasonable. Don't judge my soldering. That's the size of my soldering iron tip.